This is SpaceTime, Series 29, Episode 34, for broadcast on the 20th of March, 2026. Coming up on SpaceTime, NASA's Van Allen Probe A comes to a fiery end, the agency's Mobile Launcher 2 project put on hold, and a spectacular failure for a Japanese rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
After a mission lasting some 14 years, NASA's Van Allen Probe A spacecraft has entered Earth's atmosphere in a fiery death plunge, burning up over the Pacific Ocean. Between 2012 and 2019, the spacecraft, together with its twin, Van Allen Probe B, flew through the Van Allen radiation belts, rings of charged particles trapped by Earth's magnetic field, to understand how the ionized particles were gained and lost. The belts shield Earth and its inhabitants from cosmic radiation, from solar storms and the constantly streaming solar wind, all of which can be harmful to humans and damage technology, so understanding these belts is important. Last week, the United States Space Force predicted the 600-kilogram probe was experiencing enough orbital decay to re-enter the Earth's atmosphere within a few days. As expected, most of the spacecraft burnt up as it passed through the atmosphere, but some components made out of titanium and stainless steel were expected to survive the heat of re-entry, splashing down in the ocean. Originally designed for just a 2-year mission, the Van Allen probes A and B were launched back on the 30th of August 2012 and gathered unprecedented data for almost 7 years on Earth's 2 permanent radiation belts, named in honor of the scientist James Van Allen. NASA ended the mission after the 2 spacecraft finally ran out of fuel and were no longer able to orient themselves towards the Sun. The Van Allen probes were the first spacecraft specifically designed to operate and gather scientific data for many years inside the radiation belts. It's a region around our planet where most spacecraft and astronaut missions try to minimize their time there in order to avoid damaging radiation. The NASA mission, managed and operated by Johns Hopkins University Applied Physics Lab, made several major discoveries about how the belts operate, including the first data showing the existence of a transient third radiation belt, which forms during times of intense solar activity.
We're learning much more about the dynamics and the evolution of the radiation belts, why they're changing, how they're changing. We've seen them almost disappear completely. We've seen new belts that we didn't even know exist appear. Traditionally, we've always thought of an inner and an outer belt. What we've found now is that the outer belt has much more structure in it, and there is a storage ring, a separate ring, almost a permanent third belt that's there that we think is actually the home to the particles that are filling the outer belt.
This 2-year mission didn't quite get off the ground as originally expected. It was first delayed for 24 hours for a technical issue, and then it was followed up by some bad weather, which eventually led to another delay.
Then Hurricane Isaac rolled into the Cape. That really put us back almost a full week. We actually had to roll the rocket back into the integration facility and shut the doors and protect it. But a few days later, we were back out again, ready to go, and it was worth every second of the stress of waiting for it. We launched at the end of August, and it was almost like the sun knew we'd launched and immediately switched on. We hadn't seen really any space weather events for really quite a long period of time, and yet within the first couple of days of the mission being up there, the sun threw a beautiful event our way. We were able to see a lot of very, very interesting science that we wouldn't have seen if we hadn't had this large event, and we certainly would never have seen it without the tremendous instrumentation on the 2 spacecraft. We've always known that there are waves and magnetic and electric fluctuations that go on in these belts, but with the more traditional 1 spacecraft, we could just see the wave and it would disappear. With the 2 spacecraft and also the most sophisticated instruments that we've flown in the belts, we're actually able to look at how these waves evolve, how they change, and how long they last. These waves are very important because they actually carry the particles that are in the belts. It's almost like the particles surf on these waves.
That's Van Allen Probe's Deputy Project Scientist Nikki Fox from the Johns Hopkins University Applied Physics Laboratory. When the mission finally came to an end in 2019, analysts suggested the spacecraft would re-enter Earth's atmosphere sometime around 2034. However, those calculations were made before the current solar cycle reached its climax, which has proven to be far more active than expected. The increased stream of particles flowing out from the Sun causes the Earth's atmosphere to wobble like a jellyfish, contracting in some places and expanding in others. In 2024, scientists confirmed the Sun had reached its solar maximum, triggering intense space weather events. And these conditions increased atmospheric drag on the spacecraft beyond the initial estimates, resulting in an earlier than expected re-entry. While Van Allen Probe A is now down, its twin still not expected to re-enter before 2030. Data from NASA's Van Allen Probe's mission still plays an important role in understanding space weather and its effects. By reviewing the archived data from this mission, astronomers can study the radiation belts surrounding the Earth, which are key to predicting how solar storm activity impacts satellites, affects astronauts, and interferes with communication systems, navigation signals, and even power grids on the ground. By observing these dynamic regions, the Van Allen probes contribute to improving forecasts for space weather events and their potential consequences. This is SpaceTime. Still to come, Mobile Launcher 2 project put on hold, and a spectacular failure for a Japanese rocket. All that and more still to come on SpaceTime. Last week's announcement of changes in the Artemis moon launch schedule has now resulted in NASA pulling the plug on further work on its Mobile Launcher 2 project, which had been under construction at the Kennedy Space Center in Florida over the past 2 years. While the current Mobile Launcher 1 was built for Artemis 1, 2 and 3 Block 1 configurations of the SLS Space Launch System rockets, Mobile Launcher 2 was intended for the taller rockets planned for Block 1B and Block 2 configurations, which would appear in the guise of Artemis 4 onwards. As well as changing the Artemis 3 mission from a manned lunar landing to a low Earth orbit practice and test flight, the changes also see an increased cadence in flights to the Moon, with launches now expected to take place roughly once every 10 months, and importantly, the scrapping of the new Exploration Upper Stage intended for use on Artemis 4 onwards. The existing interim cryogenic propulsion upper stage, which was used on Artemis 1 and will also be used on Artemises 2 and 3, is based on the upper stage of the Delta 3 and Delta 4 launch vehicles. Built by the United Launch Alliance, it features a single Aerojet Rocketdyne RL-10 engine and was meant to simply be a temporary solution until the new, bigger, purpose-built Exploration Upper Stage was available. The Exploration Upper Stage was designed for use on Artemis 4 onwards and was to be taller and more powerful, designed to carry far larger payloads into translunar orbit. To do this, instead of having just one, it was to be fitted with 4 RL-10C3 engines, and it would have become standard for Blocks 1B and Block 2 versions of the SLS. In order to accommodate the new larger rocket, NASA decided to rebuild one of its existing spare mobile launchers, Mobile Launcher 2, to mate with the SLS equipped with this new taller upper stage. But now with the new purpose-built Exploration Upper Stage scrapped, NASA will instead use an upper stage based around the United Launch Alliance's Centaur's second stage, which is used on the Atlas V and Vulcan launch vehicles. Known as the Centaur 5, this upper stage will be equipped with 2 RL-10 engines and will be able to be accommodated on the existing Mobile Launcher 1 structure. So, what happens to Mobile Launcher 2? The problem is it's already 90% complete. Primary contractor Bechtel added the last modular block to the tower in the middle of last year, bringing its total height to some 65 metres. And construction on the entire project was expected to be complete before the end of this year. As to what happens now, well, that remains to be explained. This is SpaceTime. Still to come, a spectacular failure for a new Japanese rocket, and later in the science report, why some domestic house cats are prone to chronic kidney disease. All that and more still to come on SpaceTime. Space One have failed in their third attempt to become the first private Japanese company to put a satellite into orbit. The 18-metre tall solid-fueled Carius rocket fell just 29 seconds after launch from the Wakayama launch site in western Japan, spiralling back into the ground. The cause of the failure is still being investigated. The company says no major anomalies were identified within the vehicle during the flight, and it remained on course, suggesting the fault must have been with the flight termination self-destruct system. The mission was carrying a number of small satellites, including one for a Tokyo high school project. The company's first launch attempt back in 2024 ended in failure following an explosion seconds after launch. Then a second launch attempt ended when mission managers were forced to issue a self-destruct order following a technical problem aboard the vehicle. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. There are new warnings today that the rate of climate change has surged since 2015. The findings, reported in the journals Geophysical Research Letters and Nature, show that the rate has now nearly doubled to what it was back in the 1970s and much faster than many estimates. The authors say their new analysis captures a more accurate picture because it accounts for the effects of natural factors such as the El Niño weather pattern. Most climate scientists agree that warming is accelerating, partly due to a reduction in sun-reflecting air pollution. A 56-year-old man with liver failure has become the first patient to be surgically connected to a genetically modified pig liver. A report in the journal Nature claims the procedure, known as an excorporeal perfusion, involved surgeons connecting the man to a pig liver outside his body so that it could filter harmful waste products from his bloodstream. The man was disconnected from the system after 3 days to reduce the risk of infection, but there were no signs of rejection while he was connected. He later received a human liver transplant and is now recovering. Scientists from the University of Nottingham have uncovered a surprising biological quirk in domestic house cats, which may help explain why some of them are so prone to chronic kidney disease. Unlike dogs and most other mammals, cats appear to accumulate unusual fats inside the cells of their kidneys, sometimes from a very young age. The new study, reported in the journal Frontiers of Veterinary Science, discovered that cats accumulate a rare group of modified triglycerides, the most common type of fat in the body, essential for storing excess energy from food. And some of these triglycerides are showing unusual chemical bonds and branch structures, which are very rarely observed in other mammals. Many of these fats have special ether linkages and behave differently from typical dietary fats. The authors propose that this distinctive lipid buildup inside kidney cells could be an early sign of long-term stress within the kidney, potentially contributing to tissue damage over time. The hope now is to develop a supplement or modified diet to help prevent these unusual lipid structures from accumulating. Time for another Bigfoot story, and the one that's doing the rounds at the moment are claims that the FBI are investigating possible existence of Sasquatch. But as the skeptic's Tim Mendham points out, that's not what's really happening.
People are talking about in a news story that recently declassified documents revealed that the US FBI had correspondence with a Bigfoot hunter in 76-77 who offered up some hair and skin that he had collected to be tested by the FBI in labs. This actually story's been around for a while. I mean, I heard about this story years and years ago. It tends to stop there, the story, saying that FBI have tested quote, Bigfoot, close quote, hair, material, etc. And people say, well, that's fantastic. If the FBI treats it seriously, it must be true. Well, they didn't treat it seriously for a long, long time. They were finally persuaded by this rather annoying person who kept insisting that they tested it. They tested it and they came back and said it's deer hair, right? It's not a Bigfoot, it's deer. They say nothing there. So this hidden documentation that's been recently declassified but not recently declassified proves nothing. In fact, it proves the opposite of what this guy was saying. The declassified documents, the pro people will say it's been tested by FBI, it must be true. People who look at it say it's tested by FBI and they found out it was a deer.
They'll grab what they can for legitimacy, won't they?
They'll take things out of context. They'll sort of snip and sort of chop something short without the obvious conclusion that would be there, just by saying, like CIAs have tested psychics. Yes, they have, and they found them to be useless. It's the second half of that judgment that the psychics don't like saying. The fact that FBI have checked the Bigfoot or that the CIA have checked out psychics, trying to find something, some weapon that they can use. And in both cases, they found nothing. Is indicative that the pro will always take a snipping of a claim, and the skeptics will go take it a few steps further and say, but hang on, what was the conclusion?
Well, there was a Bigfoot program I was watching the other day on the Animal Planet. Not only did they talk about Bigfoot, but they also talked about using remote readings.
There's also people in the UFO community who are doing the same sort of thing, using psychics to bring UFOs down, not necessarily crash, just to bring them closer so they can look at them more closely. It doesn't help the case any if there's no evidence.
That's the Skeptic's Tim Mindham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.